Hello and welcome friend. In this new video, we will see inverse Laplace transforms of the integral and the partial method of finding the inverse Laplace transforms. We know that L inverse of integration s to infinity f of s into ds equal to f of t divided by t equal to 1 by t into L inverse of f of s. So from this, L inverse of f of s equal to t into L inverse of integration s to infinity f of s into ds. So this is the technique. By using this formula we can obtain the Laplace inverse of the functions. So if we take the whenever there are some complicated function, we can apply this technique to find the inverse Laplace transforms of the functions. Let us take example L inverse of 2s divided by s square plus 1 whole square. Now you can see that when we apply this technique, this will be easily we can find the inverse Laplace transforms. So what to do? Let us multiply by t and L inverse of integration s to infinity of the term 2s divided by s square plus 1 whole square into ds. Now here you can see d by ds of 1 divided by s square plus 1 is nothing but minus 1 divided by s square plus 1 whole square into derivative of 2s. Now see the integrate term 2s divided by s square plus 1 whole square. So the integrand is a derivative of 1 divided by s square plus 1, and so when we integrate, the derivative and integration will be cancelled, and here this minus sign t and L inverse of what is the term integration and derivative get cancel and we get s square plus 1, and here limit s to infinity. Okay, so minus t at upper limit we get, this is L inverse, we get 0 minus 1 divided by s square plus 1. Now you can see minus minus become plus. So t into L inverse of 1 divided by s square plus 1. This is a standard formula, s square plus a square. So we get this as a t into sine of t. So friend, you can see that how easily we have obtained the L inverse of this function by using this technique. Now let us see how to find how to apply partial fraction in case of finding the Laplace inverse. So whenever we have to find the Laplace inverse of 1 divided by s square minus 5s plus 6, this is equal to, here you can see that we have it as a two factors, s minus 2 and s minus 3. So these are the two factors. We write it as a divided by s minus 2 plus b divided by s minus 3, a into s minus 3 plus b into s minus 2 divided by s minus 2 into s minus 3. So this is a partial fraction method, and we get here a1 equal to a into s minus 3 plus b into s minus 2. Now we have to find the values of a and b. To find, let us put s equal to 3. So whenever we put s equal to 3, we get b equal to 1. Again in this expression this expression star. Let us put s equal to 2, and if we put s equal to 2, this term will be 0, and 2 minus 3 we get minus 1, and hence this gives us a equal to minus 1, and therefore this term s square minus 5s plus 6 will be converted into minus 1 divided by s minus 2 plus 1 divided by s minus 3. Now we easily find the Laplace inverse of this term, s inverse of s square 5s plus 6 equal to minus L inverse of 1 divided by s minus 2 plus L inverse of 1 divided by s minus 3, and we have standard formulas for that. What are that formulas? This is a minus e raised to 2t and plus e raised to 3t. Okay, so here you can see that how we can apply the partial fraction method to find the Laplace inverse transforms, and complicated function becomes simple, converted into simple form, and by using this partial fraction we can find the L inverse of this function, Laplace transforms. So friend, I hope you have get the idea of inverse Laplace transforms of integrals and how we can apply the method of partial fractions. Thank you for watching.